Okay, this is the OCR foundation paper. It's from 2018 and it is paper 3, which is one of the calculator papers. I'm going to go through each question and show you how to do the answers and try and explain my workings as I go. Question number 1. Write down the mathematical name of this triangle. Choose the list from the box. You need to know it's an isosceles triangle. It has two sides of equal length, which is shown here. Please beware, you mostly see isosceles triangles like this. I don't know why we do that in maths. They could be like this as well. That is also an isosceles triangle. Some people say it's an upside down isosceles triangle, but it is still an isosceles triangle. There is another example of one on its side, but it's still an isosceles triangle. Question 2. Write down the order of rotational symmetry of this regular octagon. Rotational symmetry is, if you put like a needle in the middle, like that, and you spun it around, how many times would it click back into its shape as it goes around? And because it is a regular octagon, it will click back into its shape 8 times. If you were asked the same question for a square, you'd do the same thing. You'd put a little dot in the middle, and that would be 4, because it would click back into itself 4 times. Question 2a. Write down 3091 rounded to the nearest 100. Well, it's between 3,000 and 3,100, and it is closer to 3,100. 3% as a decimal. There's various ways of doing it. Hopefully a lot of you will recognize it. If you didn't know, to go from a percentage to a decimal, the mathematical thing we're doing is to divide by 100. Anyway, it is 0.03. And the cube root of 27. Now, if you don't know this, you can do it on your calculator. You have got a cube root button if you have one of these, and it is a little, you can't really see it massively well, but above that one, there's a yellow one there. So if we get a bit more light on it, it's that one in there. That is the cube root button. So you need to press Shift and the cube root button, 27, and the answer is 3. The answer is 3 because 3 times 3 times 3 is 27. Moving on, question number 3. Oh no, this is still 2 part B. Complete this statement below using a number from the list. So you've got some numbers here, some are positive, some are negative, a couple of 0. And it says -5 is greater than. So if you imagine your number line, and your number line would be something like that, it would have 0 there, and it would obviously have 1, 2, 3, -1, -2, -3. -5 is greater than only one of these numbers, and it is greater than -6. Part C. Write the following numbers in order of size with the smallest first. This sort of question goes back to what you were taught at primary school about place value. How about the first column is your units column? So if there's any units column here, you look at that one first and they're all 0. So now you look at your tenths column. So that one's 0.4, that's quite low. That's 0.5, that's 0.0. So that's going to be your smallest one because that's a 4 and that's 4/6. So it is that's the smallest one. Still looking at the tenths column, we've got a 0.4, 0.5, 0.4, 0.4. So it's one of the 0.4s, and it is that one because after that 4 is actually a 0. It's not shown, but it would be a 0. So that one is the next one. After that, you've got 0.44 or 0.46. Well, 0.44 is the next smallest one. Then 0.46, and then the biggest one is the 0.5 because there are 5 tenths. Question number 3. Calculate this. If you want to put it on your calculator, you can do so. Just be a little bit careful. These calculators are quite nice because they have this fraction button here. So you can press that and actually tap it into there. So 3.6, and you go down, divided by 1.2. Take away 0.3, and it will just tell you the answer there, which is 4. You can't see it massively well, but the answer is 4. The next one, what is the square root of 12.25 cubed? Well, again, you can put this into your calculator. So the square root button is that one there, so you press that, and it is 12.25 cubed, so 12.25 You could do a cube, I think it's probably one somewhere, but I always go to the power 3 and press equals, and you might have to press your SD, stands for surds to decimal, but just press your SD button, and it is 42.875, 42.875, 1 mark, round it to 1 decimal place, 42 point, now it's 8 at the moment, but the 7 would round it up, so 42.9. Question number 4. This grid shows a horizontal line going through point A, and you can see that there. Part A, write down the coordinates of point A. So it's along the corridor and up the stairs, so it is 4, 3. Plot the point -2, 3. So it's back along the corridor, then up the stairs. So it is there. You can see I've already plotted it. The next one, write down the equation of the horizontal line going through point A. So here is the here's the line. So you're going to write down the equation of that line. The answer is y equals 3, but I just want to try and explain to you why that is, because people think it goes in the same direction as the x-axis. It should be x equals 3. Let me just try and show you. When you ever plot coordinates, we say along the corridor, then up the stairs. Well, along the corridor is your x-axis, and up the stairs is your y-axis. So you're actually plotting them like that. You're just putting in values for x and y. So this one would be, x would be 4 and y would be 3. So what I'm going to do is just write down a few coordinates that are on this line, and let's see what happens, because once you see it, you'll be like, oh yeah, that's what's going on. So this point here, point A is 4, 3. So I'll plot point 4, 3. I'll plot the point I did over here, which was -2, 3. I could plot that point there, which is just literally where my finger is, so that would be 0, 3. I could plot the point next to it there, which would be 1, 3. Plot the point next to that, which would be 2, 3. Something you should notice here, that all the y values are 3. So it shouldn't surprise you to know that the equation of that line is y equals 3. So the answer is y equals 3. If you have a line going in a vertical direction, something like that, that would be x equals, well in this case it would be 3, or x equals 2, or x equals 1. Question 5. Tea biscuits can be bought in packets of 20 or 24. All biscuits are identical in size and quality. So you get 20 biscuits for £1.50 and 24 biscuits for £1.80. This sounds like it's a best value question, so we're going to have to work out which ones are the best value. So the way I've done that is I've worked out the cost per biscuit. So if 20 biscuits cost £1.50, I've done £1.50, or I put it in pence to make it a bit easier. 150 pence divided by 20, so it's 7.5p per biscuit. I've done the same thing over here, and I get 7.5p per biscuit. Nadia says the packet of 24 biscuits is better value. Is she correct? Well, no, she's not correct, because, so Nadia is wrong, because biscuits in each packet cost 7.5 pence each, and we've shown that here. So this is how we've shown we've decided, because it does say show there in the workings. Question 6. You are given that 5y equals 4x. Find the value of y when x is 10. So 5y is 4x. If x is 10, 4x will be 40. So you've got 5y is 40. So 5 times what is 40? 5 times 8 is 40. If you are solving well, it is an equation we've solved. A lot of you will be familiar with doing this, getting y on its own. So you divide both sides by 5, because you've got 5 times y. So to undo that, you divide by 5. The next one, write y in terms of x. This one I think was quite fiddly. So what I've done, I've just rewritten it, and it wants you to get y on its own. So we need to divide both sides by 5. So that's what I've done here. 4x divided by 5, you could either put 4/5 x, or you could put 4x over 5. You could put either of those, because technically they're both the same. Although this one is mathematically, it's a bit nicer. That one will also get you the mark for it as well. Question number 7, which is on the next page. Francis has 3 cards, an ace, king and a queen. And she shuffles these cards and deals them one at a time. List all the different orders which she can deal the cards. A possible order is already shown, so ace, king, queen. You may not need to use all the rows. So whenever I get a question like this, you've got ace, king, queen. So let's do ace, queen, king. So the ace can't come first again because we've done all those. Let's put the king first. So then ace, queen, and queen, ace. And put the queen first, king, ace, and ace, king. So it's 2 marks just for doing that. Find the probability that in the 3 cards Francis deals, the king is dealt immediately in bold, so we'll underline that as well, immediately after the queen. So let's have a look and put little stars next to the one where the king is dealt immediately after the queen. So this one here, the king is dealt immediately after the queen, and that one there. And they're the only 2 where the king is dealt immediately after the queen, so that is 2 out of 6, or it is 1/3. Either of those 2 will get you the mark. Question number, part B. A counter has 3 on one side and 5 on another, so I think it's the counter is the round one. Lena flips the counter. She then picks one of these cards at random, so one of those cards is probably going to go next to it. Lena puts the card next to the counter and works out the answer. So for example, if she, on the counter where she can get a 5 and a 3, she's got a 5, and at random she picks the times 2, and that gives the answer 10. Find the probability that Lana gets an answer less than 8. You must show your workings. So what this is on about is showing every single outcome she could have. So I've done a 5 minus 1, a 5 times 2, and a 5 add 4. Then I've done a 3 minus 1, 3 times 2, and a 3 add 4. And you can see them all there, and I've worked them out. Now the question is, what's the probability she'll have an answer less than 8? So it's that one, that one, that one, and that one. So that is 4 out of the 6. So the answer is 4/6 or 2/3, because you could simplify it. But 4/6 will be fine because it does not ask you to simplify your answer. Next question. Question 8. 2 groups of students go on a water sport holiday. Each student chooses one activity, so they can choose from diving, swimming, paddleboarding, or kayaking. Students in Group A choose from, and I just read them out, and their choices are shown in a pie chart. So complete the table. So first of all, we're going to complete the table. So 5 students chose diving, and that gives us 60 degrees. So you need to work out how many degrees each one person is. Well, if 5 people are 60 degrees, then one person is going to be 12 degrees, because you do 60 divided by 5 gives you 12. So that means in all of these, you're going to be timesing them by 12. I could even show that for the last one that I didn't show it for. There. So I've put my times 12s in. Right, this one, you've got 120 degrees, so to go the other way, you can divide by 12, which is fine. On the paddleboarding, you've got no data at all, but you do know the 3 other angles. So what I've done 360 degrees, because that's how many degrees are in a full turn, and I've taken away the 60, taken away the 120, and taken away the 108, which gives me 72 degrees. And because that's 72, you divide it by 12, and that'll give you 6 people do paddleboarding. And it says complete the pie chart. So the diving's already been done. That in there is 60 degrees, and I always like to label it as I go along. 60 degrees. Don't forget, when you measure using a protractor, you don't measure from here, you start from where the one left off, so that will be here. And we're now doing swimming, which is 120 degrees. So you line your protractor up like that, you get the circular bit on the middle, and make sure that line is on the one that's already drawn. So in this case, we're starting from 0, and 120 is all the way down here. And I'm going to mark that there, and I'm going to connect that up. Now, some of you might notice that seems to be half the circle. And if you thought that, you're absolutely right, because 120 degrees, not 180, 120 degrees add 60 degrees is 180 degrees. So that was for swimming. The next one is 72 degrees for paddleboarding. So I'll put my protractor on again, set it up like this. Start from 0 and 72 degrees. That's 70, 1, 2 is there. And I can draw that one out, and then I need to label it. That was 72 degrees, and that was paddle boarding. And the last one is kayaking, which is 108 degrees, which I'm going to double check that in a minute. Kayakaking, and let's just check that is 108. You put your protractor on, measuring from the inside this time, but you're starting from 0, and that comes down to just before 110. So I'm happy that is 108 degrees. Part C. One student in Group A changes activity. There is now a new modal activity for Group A. Right, modal is a type of average, and modal is the most common. So let me make a note of that. Modal equals most common. So at the moment, the most common activity is swimming, because 10 people do it. So if one student changes activity and there's a new modal average, that person doing swimming will have to change to kayaking, because that will bring that down to 9, and it will raise kayaking up to 10, and 10 will be the most common activity. So they've changed from swimming to kayaking. Part D. The choices made by Group B are shown in this pie chart here. A teacher thinks more students chose diving in Group B than in Group A. Well, let's have a look. There's 80 degrees there do diving, and in Group A there was only 60 degrees that do diving. So you might think they're correct. But let's give one reason why they might be wrong. I've got actually given a couple of reasons. There may be more people in Group A. So what that's on about, if there are, and I know there's not, but if there were 100 people in here, actually that would be quite a lot of people doing diving. But if there were only 10 people in here, there wouldn't be many doing diving at all, because it's just under a quarter. So it does depend on how many people are in your data set. I've put a little note here. A pie chart only shows proportions. It does not show actual numbers or data. Question 9. The length of a pencil is 15.3 centimetres, correct to 1 decimal place. Complete the error interval for the length of the pencil. So what that means is, what's the smallest number it can be, so you round to 15.3, or what's the biggest number it could be, so it still rounds to 15.3. The smallest number is 15.25, because that will round up to 3, because a 5 rounds up to 2. And what we always do here, we always put 15.35. Now technically, yeah, that would round up to 15.4, but this little inequality sign here means A is less than this number. So it is not equal to that, it is less than that. On the other one, it's got the little equal sign underneath, so you can see that A could be 15.25. Okay? Question 10. 4 people take 3 hours to paint a fence. Assuming all people paint at the same rate, how long will it take one of these people to paint the same fence? Well, it took 4 people 3 hours each, so that is, if you like, 12 people hours, or 12 man hours, I think the expression is, but yeah, 12 people hours. So it would take one person 12 hours to paint the fence. Part B, how long would it take 5 people to paint the same fence? Give your answer in hours and minutes. I thought this question was really fiddly. So there was 12 hours it took in total, and there was 4 people, so they took 3 hours each. So it takes 12 hours to paint the fence. So if there's 5 people painting it, that would be 2.4 hours each. And you probably got 2 marks for getting that far. But what you need to know is, you need to know how to convert that 0.4 hours into minutes. So 0.1 hours, or a tenth of an hour, is 6 minutes, because an hour is 60 minutes, so a tenth of that is 6. But you haven't got 0.1, you've got 0.4, so you want 4 lots of 0.1, so 4 lots at 6 minutes, or 4 tenths of an hour, will be 24 minutes. So the full time is 2 hours and 24 minutes. That bit of work, and I've just done at the top, that's just to explain to you sort of what's gone on in my previous question, really. But the point is, it's 12 hours and there's 5 people doing it, so it takes them 2.4 hours each then you've got to convert the 0.4 hours into minutes. Question 11. Recipe for flapjacks only uses oats, butter and syrup. Right, first thing you do, oats, butter and syrup in the ratio 3 to 2 to 1. 3 to 2 to 1. There we go. I'll need that later on. Pirin makes 1.5 kilograms of flapjacks and he uses 600 grams of butter. Has Pirin followed the recipe? So, there are 6 parts altogether. 3 parts to 2 parts to 1 part. And the total weight of the flapjacks altogether is 1.5 kilograms. I've converted that to 1,500 grams because there's 1,000 grams in a kilogram. I hope you're okay with that. So I've divided that by 6 to work out what 1 part is. 1 part is 250 grams. So they'll take 1 part of syrup, which is 250 grams, 2 parts of butter, which is 500 grams, and 3 parts of oats, which will be 750 grams. And he's used 600 grams of butter. So no, he has not followed the recipe. He should have used 500 grams of butter. So it's a basic ratios question. They try to dress it up as something else. But all you need to do is stick with what you know. Stick with doing this, work out how many parts there are, work out how much each part is worth, and then the answer should be fairly straightforward. 4 marks for that one. Part B. Using this recipe, 200 grams of syrup are needed to make 10 flapjacks. Find the mass of oats needed to make 15 of these flapjacks. Right, so 200 grams of syrup. So this is the ratio we had before, it's the same as above. And they're telling us we're using 200 grams of syrup. So this is for 10 flapjacks. So 1 part is 200 grams, 2 parts will be 400 grams, and 3 parts for the oats is 600 grams. So all together for the 15 flapjacks, all together for the 10 flapjacks, you're using 1,200 grams. Now I need to know for 15 flapjacks, so this is for 10. So to find 15, I'm going to work out the recipe for 5 flapjacks, which I've done here. You just simply half the ingredients. So for 15 flapjacks, you need 600 and 300 grams of oats, and that would be 900 grams. So for 15 flapjacks, you would need 900 grams. I hope that's fairly straightforward. I think this bit's all right. It just leads on from the question. The only fiddly bit is knowing how to get 15. And all I've done is half the recipe for 10, so halved all of these. Done my 10, add my 15, so 600 add 300, so that gives me 900 grams. Question 12. This is a topic called vectors. It doesn't often come up in the foundation paper, but when it does, it comes up and it's relatively straightforward like this. You don't really need to know too much about vectors to work it out. You can sort of use a bit of common sense. So PQ is 3 over 4. So work out 5 lots of PQ. Well, you just times them both by 5. So it's 15 over 20. You could have a reasonably educated guess at that. I think you should be all right. Next one. You've got your vectors here, so h over 5, add 2 over k, take away 3 over 3 equals 0 over 0. Find the values of h and k. Well, first of all, do my values for h. So I've got something, add 2, take away 3, gives me 0. So that's what I've written here. 2 take away 3 is minus 1. So something, take away 1 is 0. So h must be 1, because 1 take away 1 is 0. So if you think about it, 1 add 2 is 3, take away 3 is 0. Happy days, there's your answer. For the next one, you've got 5 add k, take away 3 equals 0. So I've written it here. I'm grouping my 5 and my 3 minus 3 together, so that would be 2. So k add 2 is 0. So what add 2 gives you nothing? Well, minus 2 does. So h is 1 and k is minus 2. A bit fiddly, but you should be able to work that out. Part C for that question. A triangle is drawn on a coordinate grid, and there it is. And it says just underneath it, the vector of A to B, so that is going from here down to here, is 0 minus 8. So you're going along 0 and you're coming down 8. It's a little bit like translations, I suppose, isn't it? Anyway, use the diagram to complete the vector sum. So we're doing A to B, which they've done, plus B to C, plus C to A. So basically what we're doing is coming from here, down here, across here, and up there. So from there to there, it is 0 minus 8, which is what we've got. From here to here, it is across 6 and up nothing. So that's why it's 6, 0. And on this one here, it is across, you're going to go from here to here, you're going to have to go back across here and up there. So that is minus 6, and going upwards is 8. So minus 6 and 8. So 0, add 6, minus 6 is 0. Minus 8, add 0, add 8 is 0. Give a reason why your answer to the sum could be written down without doing any workings. Basically, you're returning to the same starting point. You know, A to B, B to C, and C to A to B, B to C, and C to A. You're finishing where you started, so you haven't actually moved anywhere. You're still in the same position. Moving on. Question 13. In this question, assume all dimensions are in centimetres. We can do that. Jess and Pete have many rectangular tiles that look like this, and it tells you about the width and the length. And she joins 3 of them together to make a larger rectangle, which you can see here. Write an expression for the perimeter of her rectangle. So if that's A add B, so's that, so's that, so's that, so's that, so's that, so's that. If that's 2B, that's 2B, and that's 2B. And all you need to do now is simplify what you've got. So you've got 1A, 2A, 3A, 4A, 5A, 6A's, 6A's. And you've got 1, 2B's, 3B, 4B, 5B, 6B, 7B, 8B, 9B, 10B. So you've got 6A's and 10B's. If you write that around the outside, it's just counting up the letters. You shouldn't really go wrong with that. An expression for the area of her rectangle is 6AB plus 6B squared. So can you factorise it? So factorising is putting it into brackets. So what you do, are there any numbers common in here and in here? Well, yes, the 6 is common, so 6 comes out on the outside. Are there any letters common? Yes, there's a B there and there's a B times B there, so B comes on the outside. Draw your brackets. 6B times what gives you 6AB, well 6B times A, and 6B times what will give you 6B squared, well 6B times B. So that is it factorised. You must know how to factorise into a single bracket before you go into your exam. Make sure you do. Part B. Pete joined some tiles together to make a different rectangle. The area of his rectangle is 8AB plus 8B squared. Draw a possible arrangement of the tiles for Pete's rectangle and write down an expression for the length and the width of the rectangle. So there's 2 you could do. I've done them both. I'll show you this one. It could be it does actually say it is a different rectangle. Oh, good. So 2B, because it's that high, multiplied by A add B, A add B, A add B, A add B, which is 4A add 4B. So 2B times that. If you want to put it like this, you can. 2B, 4A plus 4B. If you expand that out, you'll get 8AB plus 8B squared. So you could do that one. Or you could have it like this. Either one of those is absolutely fine. So your answers are either 2B times 4A plus 4B or 4B times 2A plus 2B. So whichever one you've done can go in the answer down here. Question 14. Here are the first 4 terms of a sequence. Write down the next term. Well, it's going up in 4s, so it's 22. Write down an expression for the nth term. To do that, you need to notice what it's going up in each time, and it's going up in 4s, so it's going to be 4n. And the way I do it is, how do you get from 4 to 6? Well, you add 2, so it's 4n add 2. So 4 times 1 is 4, add 2 is 6. 4 2s are 8, add 2 is 10, and for the third term, 4 3s are 12, add 2 is 14. Explain why 511 is not a term in the sequence. It's a nice easy one, this. All of these numbers in the sequence are even numbers, and they're always going to be even numbers because they're going up by an even number each time. and 511 is an odd number. So my answer is because all the numbers in the sequence are even and 511 is an odd number. Find the term in the sequence which is nearest to 511. So what I've done, I've divided 511 by 4 to give me this. So that means it's going to be between the 127th and the 128th term. So I've worked them both out by doing 4 lots of 127, add 2. Then I've done 4 lots of 128, add 2. So the one that's nearest to it is the 127th term, because that's closest to it. So down there, look, and I've actually shown what that term is, which is 510. Question 15. In July, the price of a holiday is £500. All good. And in August, the price increases by 25%. Right, stop reading it. Increase £500 by 25%. There's 2 ways of doing it. You can find 10%, 10%, 5%, which is 125, then add it on. Or if you're comfortable with using the multiplier, and what that is, it's converting that to a decimal, which is 0.25, and because we're increasing, we do the 1 add 0.25, which gives you 1.25, and that is your multiplier to increase by 25%. If you had to decrease it by 25%, you do the same thing, only here you would subtract, not add. Anyway, in August, the price increases by 25%, so it is £625. 2 marks for just working that out, fairly straightforward. In September, the price drops to £500. Work out the percentage decrease from the August price, which is here, 625, to £500 again. Percentages are funny things. You can't simply say it's 25%, because if something goes up by 25%, and it came down by 25%, it'll actually be a little bit different. If you think about £100, add 10%, that would be £110. But £110 take away 10% would be £99, because 10% of 110 is 11. So, to work out the percentage reduction, you do how much you're going to have to reduce it by. So it's being reduced by £125, because 625 back to 500 is 125, and you divide that by the amount which it is, which is 625. You do that division on your calculator, you get 0.2, which is 20%. Certainly you should be able to get 2 marks for that, and you should be able to work this last one out even if you use a bit of trial and error, even if you don't use this method. Next one, 16. Here's a right angled triangle. It's a Pythagoras question. I've labelled my sides A, B and C, and you have to find out this length here. I'll just put my workings on the table for you so you can zoom in and have a look. A squared add B squared is C squared. So A squared, which is 5.25 squared, add B squared, which we don't know, add C squared, which is 18.25 squared. So I've squared 5.25, I've squared 18.75. Notice how I'm keeping my workings very neatly there, so you can see what's going on during each step of what I do. So to get B squared, you've got to do this one, take away this one. So that leaves me with 324 for B squared, and obviously to find B, I need to square root 324, and that will give me 18. So the answer is 18 centimetres. That's a Pythagoras question. It's finding one of the shorter sides. I hope you're okay with that. Question 17. Ping chooses 4 numbers. The mode of the 4 numbers is 8, the range is 7, and the mean is 11. Right, a couple of things. As the mean is 11, the 4 numbers must add up to 44. Because to calculate the mean, you add the numbers up and divide by how many you've got. So they all must add up to be 44, because you do 44 divided by 4, which gives you 11. The mode is the most common number, so there's got to be at least 2 of them here. And the range is 7, so the biggest take away the smallest, it's got to be 7. The way I did this was, I wrote down my 2 8s, and then I thought the next thing I'm going to find is the range.
So as 8 is probably going to be the smallest number, I thought, what number, take away 8, will give me 7, and it's 15. Take away 8, which gives me 7. So I added those three up. 8 add 8 is 16, add 15 gives you 31. So that means to get to 44, we need 13 more. And those four numbers, and I believe they're the only four numbers, can give the information we need above. So a little bit fiddly for 3 marks, but you need to know your averages well, and then knowing what I've written down here, you should be able to work them out. The next one, 4 marks. It's another ratio question. They love their ratios in this paper. A box contains only red, blue and green pens. The ratio of red pens to blue pens is 5 to 9. Right, there you go. Red to blue, 5 to 9. Get that written down. The ratio of blue pens to green pens is 1 to 4. And I've written it in blue here, 1 to 4. What percentage of the pens are blue? Right, to do this, the common thing you know is the ratio that are blue. So in the first case, it's 5 red to 9 blue, and the second case is 1 blue to 4 green. I'm going to multiply this and this by 9, because then I'll be able to equate it to the ratio I had for my first one. So 1 to 4, that's the same ratio as 9 to 36. So I can say the ratio of all the pens are 5 red to 9 green to 5 red to 9 blue to 36 green. Because we're dealing in ratios and percentages, they're not actual numbers, they're just ratios. There could be 500, 900 and 3,600 for all we know, but because we're asked about the percentage, it doesn't matter too much. So anyway, 5 parts to 9 parts to 36 parts, that's 50 parts in total. How many of them are blue? Well, 9 out of the 50 are blue, so you need to convert that to a percentage. You can probably do it in your head. 9 over 50 is 18 over 100, which is 18%, because don't forget, percent means out of 100. So 18 out of 100 literally means 18%. If you knew that, well done, you're speaking Latin, or maybe Greek, I'm never quite sure. Question 19. Asha worked out this calculation. I'm not going to read it. She got an answer of 19.5 correct to 3 significant figures. Write each number correct to 1 significant figure to decide if her answer is reasonable. So that to 1 significant figure is 300. 6.94 to 1 significant figure is 7, and 3.4 to 1 significant figure is 3, and 59.4 will go to 60 to 1 significant figure. So I've written that down, and then I've just started to solve it. So 7 take away 3, that gives you the 4. So 300 times 4 divided by 60. 300 times 4 is 1,200 divided by 60. You can use your calculator for this if you like. That will give you 20. So yes, her answer was 19.5. And our answer we got was 20 when we did the rounding. So yes, her answer is very reasonable. Question 20a. Show that, I'll let me zoom in because it's a little bit fiddly this one. Show that a to the power 5 times a cubed, brackets squared, can be expressed as a to the 11. Right, you need to know that a to the power 3 squared is a to the power 3 times itself. So a to the power 3 squared is a to the power 3 times a to the power 3. So the calculation is actually a to the power 5 times a to the power 3 times a to the power 3. And if you know your index laws, you'll know that you add the index numbers here. So 5 add 3 is 11. So it is a to the power of 11. You could go into why you multiply, I suppose. A to the power 3 is a times a times a times a times a times a, which is a to the power 6. So that's what you get if you add the index numbers. But I believe what you've done there will get you the full marks. Part B, I thought this was really nasty, but I'll talk about it. You need to know that 1 over 25 is 5 to the power minus 3. 5 to the power 3 is 125, but if you want to put 1 over it, it'll be to the minus 3. So you sort of either know that or you don't. 25 to the power 9 is the same as 5 to the power 18, because 25 is 5 times 5. So it's done 5 times 5, 9 times. So 5 times 5 times 5 times, and so on, that will be 18 times. So you've got 5 to the power minus 3 times 5 to the power 18, and that gives you 5 to the power of 15. That's a really nasty question. Unless you're really, really hot on your index laws, don't worry too much about it. Right, question 21. The diagram below shows two triangles. Prove that the two triangles are congruent, and congruent means that they are the same. So, look, you might not have a clue what congruency means, but there's marks in it for you. There's a couple of angles here. Work them out, because you've got 180 degrees in a triangle. I've worked them out. That one's 44, that one's 56. And because there's 180 degrees in a triangle, that's my reason for it. You'll get 1 mark for doing that. So you need to know that congruence means the same, and that means that length AC in both triangles is the same length, because it is common to both triangles. It is in both triangles, and you just see it there. So you can say that length AC is the same in both triangles. You can say that both of these angles here, so that is ABC and ADC, are 80 degrees, and I've literally written that there, and that's how you write an angle, ABC, ABC. I've even underlined the B to show that's what I'm talking about. Angles BAC and ACD are the same. They're both 56 degrees, so that's 56 and that's 56, and the last two are both 44 degrees. So the triangle is congruent because we know that one length is the same and at least two of the angles are the same. In fact, we know that 3 of the angles are the same. So you could use the angle fact, angle side angle, or angle side, but this is the key bit here. That was the bit that will get you the marks. Question 22, which is the last question. I had a story from LSA in an exam. A student started laughing at this question, and I asked her why. She said Earth and Pluto go around the Sun, and their distance to the Sun varies. So here's a little diagram of what's happening for you. And the exam board have seen in their wisdom to tell you that it's not to scale, just in case you weren't aware that this is the actual size of the solar system in which you're living. Anyway, it's the last question. It's on standard form, but it's actually quite nice. It says, show that the closest distance of Pluto to the Sun is roughly 30 times the closest distance of the Earth to the Sun. Well, here's the distances. So you've got to show that this number here is roughly 30 times bigger than that number there. So what I've done, I've just multiplied the distance of the Earth by 30, and you get that, and look, that number is very similar to this number. Another way you could do it is to divide the distance Pluto is from the Sun by the distance Earth is from the Sun on your calculator, and you get the answer 30.2. I want to show you how to do that in case you didn't know how to put standard form into a calculator. I hope this calculator shows up. If I tilt it towards the window, it works a bit better. So the calculations we're going to put in 4.44, and standard form is this button here, times, or can't see it, there you go, times 10 to the x at the bottom, to the power, this is Pluto's one, isn't it? So that's to the power 9. You divide that by 1.47, and again, look, using the times 10 button there, to the power 8. You might have to press SD after this, I expect you probably will, and there you go, so it's 30.2, it keeps going for some time. But yeah, so that shows it's roughly 30 times the distance. Only 2 marks for that, and you can use your calculator. So if you can do that on your calculator, good stuff. Part B, last question. Give a reason why we cannot use this information to say the distance of Pluto to the Sun is always 30 times the distance of the Earth to the Sun. I ought to reiterate in the question, the table shows the closest distance of the Earth and Pluto will go to the Sun is these. So these are the closest distances, and because the orbit is elliptical, we'll obviously be going a little bit further out. So the reason we cannot say the distance of Pluto to the Sun is always 30 times the distance of Earth to the Sun is because the distance varies, and the data above says that the distance given are the closest distances. Obviously, if they give the distances that are further away, it will probably be more than 30. Right, for these papers, Foundation from OCR, you're looking at roughly half marks for a grade 4. It could go up as much as to 51, 52, maybe even 55. So don't settle for 50% if you're after that 4. Aim for higher. If you're after a grade 5 from it, you're looking around 65 up to 70%. I think this year it was around 65. I hope that was useful.